Okay, let's do the free response questions here. We have an electron across a potential difference. Find the work in joules done on the electron. So work is going to be, and we can always go to the reference table if you need, voltage times charge. If I rearrange that equation, W equals VQ. We're going to show all work. The voltage is 2.5 times 10 to the fourth, 2.5 E4 volts. The charge is an electron, so 1.6 times 10 to the negative 19th coulombs. So the answer should be in joules right here. 2.5 E4 times 1.6 E negative 19. And I think it's probably okay to write it either way. It's probably preferential on the reference, on the Regents exam to write it like this, but that should be fine too. I did leave off a negative sign on the charge because it doesn't matter. So it should be 4 times 10 to the negative 15th joules. Pretty small. Okay. We are now going to plot some data. Length versus resistance. This looks like Ohm's law. Okay. Let's see if it follows Ohm's law. If it follows Ohm's law, you should get a linear graph right there. Oh no, sorry, this is not Ohm's law. This is resistivity. It should, like, R equals rho L over A. So in theory, R over L, R should be direct proportional to L. So it should be a linear relationship too. Okay, length. We're going to go up to 20. So let's think. 5, I don't know. 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Assuming I do this 1, 2, 3, 4. Oh, I'm off one. Well, okay, 5, 10, 15. Should have done this in pencil. 21, 20, 25. Okay. So at a length of 5 meters, its resistance is 1.6. So for just a little, so that's 1.5, 1.6. Looking right there. At a length of 11, its resistance is 3.8. So just a little bit short of 4. 3.5. Okay. At 16, it's 4.6, so that's 4.5 right there, so that should be a little bit over 4.5. At 18, it's 16, it's 4.6, it's 18, it's 5.9. There we go. They did a good job of not making this totally linear. And at 23, it is 7.5. Smack down there. Okay. Draw a best fit line. Let's do this with a ruler probably. Except I don't have one, so let me just use a piece of paper. Going to assume this should go through 0, 0. Doesn't have to hit every point. Looks pretty good. Okay, calculate the slope. Delta y over delta x. If you want to set that point 0, 0, and this point looks like it is, oh my gosh, pretty much on the dot. 23, 7.5. So you could be y2 minus y1 is 7.5. Let's get the right units because it's ohms. Minus 0 ohms over x is 23 meters minus 0 meters. So you end up getting 7.5 over 23. Is 0.326 ohms per meter. Works. If you wanted to, you would recognize that R over L is equal to the resistivity over A. So you could use different units, but I would just leave it with that. R over L should be equal to resistivity over A. for what it's worth. Okay. I think that's good. Copper wire. Copper, that might be important. We'll see. Is connected to V over I, so determine the resistance of the copper wire. So in this case, we have resistance is just going to be V over I. I mean, you could just pick 2 points on this, honestly, but let's just go with the slope. So the slope, I'm going to do a simpler version here, rise over run. So it goes from 0 up to 20 volts, and it goes run from 0 to 0.08. And we don't want to leave it like that. We want to do 20 divided by 0.8. So it's 25. And let's get the right unit. Ohms. You could do volts per amp if you really wanted to, but ohms is the right one. A lightweight sphere hangs by an insulating thread. You want to figure out if it's neutral or electrostatically charged. She has a negatively charged rod and a positively charged rod. She does not touch the sphere with the rods, but runs tests by bringing them near the sphere. What is a test that would prove that the sphere is neutral? Oh, interesting. Okay. Well, imagine you had a negatively charged rod, and if it was attracted, well, you might want to say it's positive, but the reality is it might not be. It could be neutral, and boom, 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 boom. So you could do a negatively charged rod, take it away if you see a force of attraction, then try the same thing with a positively charged rod. And a positively charged rod is still going to get a force of attraction with a neutral object. So both rods attract. And if you're doing a test, you can say test to see if both rods attract the sphere. If so, it's neutral. If the positive, now you can't bring a negative near it and say the negative is going to attract a positive, because it will, but if you bring the positive rod close and you sense a repulsion, that's telling you the sphere is positive, because a neutral will attract. But a positive is the only way to get a repulsion if you get 2 positives. Okay, proton starts from rest, gains a bunch of energy. Find the potential difference. Potential difference is voltage between 2 points. V equals W over Q. We know the energy is 8.35, E negative 14. We know that it is a proton, so the charge is 1.6, E negative 19. Put that in your calculator, you get something to the 5th, 8.35, like 4 to the 5th. E negative 14 divided by 1.6, E negative 19, gets me 5.22 times 10 to the 5th. Let's get the right units in here. So we need to show our work, including equation substitution with units. So work is in joules, Q is in coulombs, V is in voltage. There you go. Full points right there, even if it's not as neat as I'd like it. Okay. Circuit symbols. Draw a circuit showing how the lamps and battery are connected. So 3 lamps are connected with a battery of constant potential. So a battery looks a little bit like this. Boom. The current potential difference are listed in the data below. Ooh, this is a little tricky, but you'll notice that they are all 40 volts. That tells you that everything is in parallel. So these lamps like this, and if you don't remember what a lamp looks like, that's totally fine. You look here, you see a lamp, it's got a circle with some loops. There we go. Battery, 3 lamps in parallel, so they should all have the same voltage difference, 40 volts. What's the potential difference supplied by the battery? 40.1 volts. It's the only way to get them all to be 40 volts is that they have to be in parallel. And I know this because if it was in series, then they would not all have the same potential difference because they have different resistances. If they all had the same resistance and the same potential difference, that would be possible to get a series circuit. Okay, determine the equivalent resistance of the circuit. So this is a bit of a weird one, but 1 over R equals 1 over 89, and I'm not going to put in units, it doesn't ask me to. 1 over 365, 1 over 143, which equals, and this is weird, but let's see, 1 divided by 89 plus 1 divided by, I'm going to put parentheses, 1 divided by 89 plus 1 divided by 365 plus is 1 divided by 143 gets me 0.021. Now that's 1 over R, so R is equal to the inverse of that, 1 over 0.021. So I could just say answer raised to the -1 would work. And I get 47.7 ohms. Okay, if lamp 3 is removed from the circuit, what would be the value of the potential difference across lamp 1? So if lamp 3 goes away, boom! Well, still a parallel circuit, still have 40 volts, so it should still be 40.1 volts. That will not change. If lamp 3 is removed from the circuit, what would the value of the current in lamp 2 be after lamp 3 is removed? Interestingly enough, that won't affect anything either, because the current I is equal to V over R. While the voltage drop for lamp 2 is still going to be 40.1 volts, the resistance of lamp 2 is still going to be 365 ohms. So the total current's going to change because there's less current going through. You remove a resistor, you actually add resistance to it. 40.1 divided by 365 equals 0.11 amps. So that is the amperage through this particular second lamp. Okay, we got 100 meter long of nichrome wire. Calculate the resistance. R equals rho L over A. Now, nichrome has a weird number, 150 times 10 to the -8. 150 E negative 8. Doesn't ask me for units, so I'm going to leave them out. They are ohm meters, though. L, I'm being bad physics teacher by leaving out units. If I had more space in this, I would put them in. Length is 1 meter. Fine, I'll put them in. Ohm times meter. Area is going to be meters squared, so that gets rid of stuff. 7.85 E negative 7. So let's do this meters squared. So the meter squared cancels that meter, cancels that meter, which leaves you with ohms. 150 E negative 8 divided by 7.85 E negative 7 gets me 1.91 ohms. Determine the current in the wire. I equals V over R. 1.5 volt battery. Resistance is 1.91 ohms. Equals 0.785 amps. Okay. There we go, 785. Sorry if that's hard to read. An electric circuit contains two 3 ohm resistors. Draw a circuit diagram. They are in parallel with the battery. It contains a voltmeter that reads the resistance across one of them. So they're in parallel. I can draw it like this. There's a voltmeter. This voltmeter is reading the voltage drop of this particular one. Total resistance, 1 over R equivalent is equal to 1 over 3 ohms plus 1 over 3 ohms. Watch, I'm putting units in there. I didn't put the equation, so I need to make sure I do that. 1 over R EQ equals 1 over R1 plus 1 over R2. There's my equation. Not a lot of space, sorry about that. 1 over 3 plus 1 over 3 You can add these up easily as 1 over 2. I'm sorry, 2 over 3 ohms. That's 1 over Req, so Req is the inverse of that, so 3/2 ohms, or 1.5 ohms. 2 compasses. The North Pole points to the end A of the magnet. Okay. So north is attracted to south. So that's going to be south. That's going to be north. Use another compass needle here. So the northern compass needle is going to point away. And the southern compass needle is going to point towards that. North is attracted to south. So if that's south, then that's north. And if that's north, then that's going to be south. Oh my gosh. Words. Lots of words. Always fun to read these. Let's just read the question. Determine the order of magnitude of the electrostatic force between the electron and the proton. Well, I probably don't even need to read that yet. It doesn't ask me for calculations either. So it's just K Q1 Q2 over R squared. 8.99 E9. I don't have to put units in because it doesn't ask me for that. A proton is 1.6 E negative 19. An electron's the same, so I can put it in there, but I'm just going to square it instead. Make sure you don't multiply it by 2, just square it over R squared. So what's the distance between them? They have an approximate radius of, so that's 1 E negative 10. Don't write 10 E negative 10. You're going to make a mistake if you do that. 1 E negative 10, and that is squared. So let's put this in. 8.99 E ninth times 1.6 E negative 19. I don't like that. Parentheses, 1.6 E negative 19th squared. Divided by 1 E negative 10 squared, which is equal to 2.3 times 10 to the negative 8 newtons. It's a pretty small force. Okay. Determine the order of magnitude of gravitational force. Oh my gosh. It says order of magnitude. I didn't notice that at first. So if you want the order of magnitude is just the negative 8. So it's just like whatever the power is raised to is negative 8. But let's find gravitational force. F sub g equals g m1 m2 over r squared. G is equal to, and we can find this all on the first page of the reference table, 6.67 E negative 11. Mass of a proton is 9.11 E negative 31. That's electron. Proton is 1.67 E negative 27. So F is equal to G m1 m2 over r squared. R again is 1 E negative 10 squared. Most easy mistake you can make is putting this in the calculator incorrectly. Times 9.11. Put parentheses around that. 31 times 1.6. Again, put parentheses. 1.67 E negative 27. Really easy to make mistakes. If you don't put parentheses in, 1 E negative 10. I'm going to square that. Again, parentheses. Gives me answer of 1.0 times 10 to negative 47. So you can see it's much, much smaller. And if I want to get an order of magnitude as negative 47, or you could say 10 to the negative 47th, either way works. There's an apparent contradiction. The electromagnetic force also governs atoms. All commonly observed phenomena could be understood with only the electromagnetic and the gravitational force. Using the response, explain why gravitational attraction is negligible for the hydrogen atom. So you can just say the force of static electricity is much, much, much larger than the gravitational force. 10 to the negative 8, 10 to the negative 47. So this is pretty much negligible compared to that. So much smaller. I think I did that whole problem without actually looking at the actual text. Okay, we got a couple batteries, resistors, and stuff like that. We got a 12-volt battery. Use the symbols, draw a complete circuit. We got an ammeter, voltmeter, resistor 1, resistor 2 in parallel with the battery. So we need an ammeter connecting resistor 1. So let's call that R1. Well, we need an ammeter there. That gets resistor 1 right there. A voltmeter to drop the potential. So we don't want the voltmeter to get the resistor, the ammeter in there either. So there's R1 with the ammeter to measure current, voltmeter to measure voltage, and now let's do resistor 2. There we go. If the total current is 6 amperes, determine the equivalent resistance of the circuit. So let's think about it. The total equivalent resistance of this circuit. So that is 3 ohms. We don't know what this is, but we know that's 12 volts. We know that the total current, you can use Ohm's law at any given point, right? So if you say R equals V over I, that works for individual elements, which have a voltage of 12 volts, by the way, because it's a parallel circuit, and a resistance, but we don't know what the resistance is. So we're not going to find the individual current of this. We could find the individual current of that. 12 volts over 3 ohms gets us 4 amps, but we can even simplify it a little bit. So let's do it this way. Let's do the whole circuit. R is V over I. So 12 volts over 6 amps. 12 over 6 is 2 ohms. So that's the easy way to do it. It's just R equals V over I. Got a substitution with units for the whole circuit. So you can, I mean, there's again other ways to do it. V over R is equal to current. So 12 over 3 is equal to 4 amps. So there's 4 amps going through here, which means that there's 2 amps going through there. So you could do it other ways. You could say, hey, if this is got 4 amps and 3 ohms, then that would be 1 over R equivalent is equal to 1 over R1, just 1 over 3 ohms, right? Plus 1 over R2. Now we don't know R2, but we know that R2 has a certain voltage and a certain current. So R2 has got to have, I'm sorry, R1 has got to have 2 amps going through it because the total adds up to 6, 12 volts. R equals V over I, 12 volts over 2 amps gets us 6 ohms. Makes sense. It's got to have twice as much resistance if it has half as much current. So 1 over 3 plus 1 over 6 ohms right there is equal to 1/6 plus 3/6 is equal to 4/6. That goes underneath, by the way. So if that's the case, REQ equals 6/4. So 1.5. Why'd that not work out? What did I do wrong? I'm checking my work. .12 volts, 6 amps. 12 volts over 6 amps. It should be 2 ohms. V equals R. What did I do wrong? No, there's 3. So it's got to be. I'm going to pause and think about this for a second. Okay. I found my mistake. Here we go. 1 over 3 is 2/6. So you get 2/6 plus 1/6. Add them up, you get 3/6. The inverse of 3/6 is actually 6/3. 6 over 3 is 2 ohms. So that's a longer way to do it. I did it twice. I confirmed my results despite making a math error the second time around. Okay, 137. What's the resistance of R2? So we've got 2 resistors. We know the current is 1 amp. So, and we got an 8-volt source. So right here at the source, we know Ohm's law is going to hold true. V equals IR. So R equals V over I. 8 volts over 1 amp. 8 volts over 1 amp is 8 ohms. So total resistance is 8 ohms. That's 2, and these are in series. You got to add them up. They add 8. So we can say 2 ohms plus X is equal to 8 ohms. So X is equal to 8 minus 2, or 6 ohms. There we go. Notice I have an equation with substitution with units and stuff like that. What's the power of the circuit? So we can, again, instead of doing the individual powers, why don't we just go with the whole thing? We know that the equivalent resistance for the whole circuit is 8 ohms, right? So let's look at the power equation. We know the voltage. We probably know the current. So there's lots of ways to do it. We could do VI, we could do I squared R. They should do all the same. P equals VI equals I squared R equals V squared over R. So if the voltage is 8 and the current is 1, and we need volts and we need amps because it asks for work, 8 times 1 is 8 watts. Now in theory that should equal I squared times R. So 1 amp squared times the resistance of 8 ohms, which we figured out over here. So 8 is equal to 1 squared times 8 is equal to 8. So 8 watts equals 8 watts equals, let's see, V squared over R. V squared, so 8 volts squared over the resistance, which is 8 ohms. 8 times 8 divided by 8 is still 8. And again, you get watts. So 3 equations that give us the same result, either way. And that does it. In case you missed it, here's a copy of the answer key. Feel free to pause and look at it more carefully if you want. You should have a copy of this, hopefully. And finally, this page right there. Hoping I didn't make any mistakes. You notice that 10 to the negative 8th, 10 to the negative 47th. So they were just looking for orders of magnitude with those 2 questions. So you didn't even need, and you could have just said negative 8 or negative 47. Those are 132, 133. So these 2 questions here that we did, negative 8, negative 47, you can ignore all the other stuff because it asked for order of magnitude. If they had gotten rid of the order and they just had determined the magnitude, you'd have wanted the 2.3 in there and you wanted the 1.0 in there too. Okay, thank you very much for watching.